we now discuss the solution of the problem from the section Differential Calculus, which has appeared in the Joint Entrance Examination Main held on 28th June 2022 in the second shift. The problem is related to the application of L'Hopital's rule. The given question is, if limit extends to 1 of the quotient, in which the numerator is sine of 3x square minus 4x plus 1 minus x square plus 1 by the denominator 2x cube minus 7x square plus ax plus b is equal to minus 2, then the value of a minus b is equal to, we are given a quotient whose limit as extends to 1 is given to be minus 2, required to find the value of a minus b. We now discuss the solution of the problem in detail. We are given limit extends to 1 of this quotient is equal to minus 2. Agreed. We notice that limit extends to 1 of the numerator. So if you take the numerator, and this will be sine of, as extends to 1, 3x square minus 4x plus 1 is 0, sine 0 is 0, minus x square, that is 1 square plus 1, minus 1 plus 1 is 0. So it means, notice that the numerator is 0 as extends to 1. If the denominator is not 0, let us say, as extends to 1, then the limit extends to 1 of the above, then the limit extends to 1 of the above will be 0, which is not true because it is given to be minus 2. Therefore, the denominator must be 0 as extends to 1. That means limit extends to 1 of the denominator is 2x cube minus 7x square plus ax plus b is equal to 0. Taking the limits, we get 2 minus 7 plus a plus b is equal to 0. This will imply a plus b is equal to 5. Let's call this as the relation 1. Now, we apply L'Hopital's rule and obtain limit extends to 1. The derivative of the numerator. The derivative of the numerator is, the derivative of sine is cos, and the derivative of 3x square minus 4x plus 1 is 6x minus 4. We apply chain rule. Minus the derivative of x square is 2x by the derivative of the denominator, that is the 6x square minus 14x plus a. Now again we see, as extends to 1, the numerator is 0. How? As extends to 1, cos of, this is 0, cos 0, that is 1 multiplied by 6 minus 4, that is 2. 2 minus 2 into, as extends to 1, 1. 2 minus 2 is 0. Again, we see, since the numerator is 0 as extends to 1, to obtain a finite limit, namely minus 2, we must have the denominator is 0 as extends to 1. This implies limit extends to 1 of the denominator. Now the denominator is 6x square minus 14x plus a is equal to 0. Now applying the limit, we will get 6 minus 14 plus a is equal to 0. This will imply a is equal to 8. Let's call this as the relation 2. From the relations 1 and 2, a is 8, substitute in equation relation 1, you will get a plus 8 is equal to 5, a is equal to b. A is equal to 8, you substitute, 8 plus b is equal to 5, b will be minus 3. So from 1 and 2, we get A is equal to 8, B is equal to minus 3. We want A minus B. That will be 8 minus of minus 3. That is 8 plus 3, that is 11. So the answer to this question is 11. And that is the detailed discussion of the solution of a problem which is related to the application of L'Hopital's rule from the differential calculus. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.